Hello, my name is Georg. I'm a systems engineer at Bitlismen. Today I'm going to demonstrate our joint solution with Opal-RT for a mixed power microgrid systems. This revolutionary approach allows to interconnect real physical hardware with PHIL simulation and enhance the research capabilities in the energy sector. In addition, this approach makes the PHIL accessible for undergraduate and postgraduate students. In this setup, I will demonstrate how the real power flows from the HL simulated digital microgrid to the physical microgrid and vice versa. Now let's see what the system consists of. Here we have a small microgrid setup that includes indoor solar power generation source, outdoor solar power generation source, power transmission line with step-up and step-down transformers, distribution substation with a double busbar, physical loads, other components to form a microgrid, Opal-RT bench consisting of OP4510 real-time simulator and OP8110 4-quadrant amplifier, and a SCADA software that monitors and controls the entire system. So we have three different renewable energy sources. The indoor PV system works in off-grid mode and through the physical power transmission supplies the simulated RLC load implemented in Opal-RT simulator. The outdoor PV system works in on-grid mode and is synchronized to the mains grid via grid tie inverter. The simulated wind generation source that is implemented in Opal-RT simulator has two branches. One of the branches supplies the physical load on the output of the physical distribution substation, and the second one supplies another physical load on the output of the manual transfer switch. In this setup, all the items that are inside dotted rectangulars are physical components, and the ones that are inside the cloud are digitally simulated. I have already implemented all the physical connections, so let's run the system. Now when the system is running, let's see what we have inside the SCADA software. In the home screen, we have a whole single line diagram of our system. Here we can monitor the statuses of the switch gears and some measurement data. On the second tab, we can control the physical switch gears, transformers, bus bars, and also sunlight of the indoor PV system. On the next tabs, we have the real-time power measurement data like waveforms, RMS values, frequencies, harmonic analysis, etc. There are two options to run simulated models. The RTLab software that allows to run the Simulink models on the Opal-RT simulator, and another option is the test drive software that allows to run the Simulink models and monitor and control the model from the LabVIEW panel. Here we also have a single line diagram of the simulated parts, control over the simulated switch gears, RLC loads and wind speed, and the power measurement data. Let's run the Opal-RT simulator and try out several things. Now on the test drive software, we will connect the switch gears of DER2 and DER3. Okay, and now we can go back to the SCADA software. Now I will connect the manual transfer switch, which will connect the load to the DER3 and also the bus 1 of the bus bar. Here on the next tabs, we can see the voltages generated by the simulated wind model and the real current flow that flows from the digital grid to the real physical loads. Here we can see the RMS values of the electrical parameters, the frequency generated by the wind turbine. We also have the power analysis, including the active power, reactive power, and apparent power. We have the power factor and harmonic analysis, which includes the total harmonic distortions for the voltages and currents, and harmonic spectrum, up to 64 harmonics. Now we will turn on the indoor PV system, which will supply the simulated RLC load. For that, I will specify a certain sunlight. And here we can go to the test drive software and manipulate with the simulated load parameters. Here we can change the resistance, we can turn on inductors and capacitance. Now let's specify resistance value, and we can go back to the SCADA software. So here we can see the voltage generated by the PV system and the current consumed by the simulated load. We can also turn on inductor. And we can change again resistance value. Here on the RMS graph, we can see how was the current change when we were manipulating with the load parameters. Hope you enjoyed the video. Don't forget to subscribe to our YouTube channel and check other videos. Thanks for watching and stay tuned.